Hello statistics class. I wanted to make this video to continue our discussion of error types and power, just with some important notes and a further example of a hypothesis test. Before we get to that, I think we definitely need to discuss some of the basics of inference as after our first quiz. So this is going to be the cool down for our first quiz in Unit 1. This first quiz in Unit 1, I think several students usually find difficult because they really haven't grasped the main ideas in inference yet, and that's why they find it difficult. Once you grasp those ideas, you can apply them to all the different types of procedures that we'll be learning, and they won't really change that much, just the mechanical equations in those procedures will change. So let's go over some of the things that you really need to be aware of. So first, this is just several of the mistakes, common misconceptions, and standard things that we definitely need to be comfortable with as we move forward with inference. So first of all, there have been three different quantities which involve some kind of, I'm going to say P, okay? One of those quantities, let me make like a little bulleted list here. So one of those quantities is, I'm going to say italic P, P denoting the parameter for a true population proportion. Now we're not going to stick with just proportion procedures, so we'll move beyond this soon, and I think this little bit of confusion will go away. But the P for proportion parameter is the true value of whatever percentage you're seeing in some kind of population of interest. So you have that. Of course, we also have P, I'm just going to say P hat. You guys know the symbol for that, right? I guess we could write it the right way, but we'll just leave it for now. So P hat denotes or stands for the statistic which comes from our sample in our observational study or our experiment, something that we measure, so something measured. And that's really the basis of statistics, is looking at the variations in that p-hat, right? And trying to quantify them and decide whether something unusual is going on or whether something is not that unusual, and p is probably the true value, the p that we think p is, okay? And then finally, what I think a lot of you are still quite confused about is p-value. So p-value is, and we need to know this definition precisely. You should be able to whip it out on an instant. So I think it was in your reading guide. That was what we opened class with today. If you missed class, we were looking at the Chapter 21 reading guide and going through it very carefully. I think just about everybody in class needs to go through and read those segments of Chapter 21 again, and you need to check over the key very, very carefully that I've posted on Moodle for the Chapter 21 reading guide. The book does an excellent job of going through the conceptual language in this section. You need to read it, rephrase it as you're reading it, add extra little anecdotes of your own. Very important that you do that if you want to be successful in the remainder of AP Stats. So what is a p-value precisely? So a p-value is, number one, put that in a little clause of its own, a probability. The p there does not stand for proportion, so it's easy to confuse right now, but it's a probability. What is it the probability of? So this p-value represents the probability of, and this is the part you need to be 100% certain on, it's the probability of finding results, let's go down, finding results as extreme or even more extreme than your statistic. So for us so far, our statistic will be p-hat, so it's the probability of finding a p-hat as far out or as extreme as you saw, or something even farther out, given that H sub O, or the null hypothesis, is actually true. Okay, this is a very important condition. idea that you know exactly. So let's even put that in the equation form. So p-value equals probability of our statistic, or worse, more extreme, given h sub o true. Let's also visualize this as a picture, and let's talk about the power of a couple of the issues of the power of a test while we're doing that. And we'll continue our conversation in a moment. So let me get my draw tool out here. So let's just picture the kind of curve that we're going to be computing these probabilities on, which is of course a z-curve. So I'm going to now come down here and draw a nice z-curve. Okay, so it's probably not going to be that nice, but I'll do my best to make a nice symmetric curve. Okay, good enough. So when we run a hypothesis test, we have a null hypothesis, and that null hypothesis says we assume something about a parameter. For right now, we're looking at just proportions. So we assume the parameter is actually right here in the middle of our z-curve. And then we go and we take some measurements. We find a statistic based on, how many did or did not do some variable of interest. And we take some measurements and we formulate a p-hat, right? So we get a p-hat from our sample, and p-hat might be on this side or on this side. Let's just imagine that p-hat fell down here this time. So there's p-hat over on that side. So it depends what our hypotheses were. If we had h sub o was that p equals some number, maybe it's, I don't know, 35%, and our h sub a was one-tailed. Let's say we were one-tailed on this. We had p was less than 35%. From the drawing that I have right now, it looks pretty likely that we're going to reject when we do our test, our hypothesis test, because p-hat looks fairly different from p. It's down here in the tail. It looks fairly unlikely. So the p-value is this percentage right here, this probability. This guy is the p-value, whatever that little red area is. So I guess I should have made it red. But anyway, I think you get the point that the p-value is that percentage. It describes how rare it was to see this p-hat if indeed this p is the middle of your z-curve distribution. So if that's really a small number, then it's pretty unlikely that this p is actually the middle of your distribution. It's pretty unlikely, in other words, that this p is actually true if this p-value probability is small. So that's why we always say that small p-values lead to rejections, large p-values do not provide evidence against the null hypothesis. We don't say large p-values confirm or accept the null hypothesis. We say they provide insufficient evidence to reject it. We don't have enough evidence of something unusual occurring. Okay, so let's write that down also in our little notes. Let's go back to our text and scroll down here a bit and say second, large p-values. Let's go with small first, because that's what I said first. So small p-values provide evidence, since they are small chances or small probabilities of seeing what we saw in our sample. So they provide evidence against h sub o, or the null hypothesis. Let's clean this up a little bit. Large p-values are large probabilities of seeing what we saw, so the large p-values do not provide evidence against h sub o, since they're large probabilities. So these kinds of results imply that we have insufficient or not enough evidence to decide against, or in other words, reject our assumption in the null hypothesis. So it's very important. You can see there's a lot of wording here. So this is a very wordy part of statistics, but it's very important as you prepare for college that you learn to digest these kinds of logical statements, because they're definitely going to continue to grow more complex depending on what field you choose. So very important that you take the language, you think about it in your own terms, you write it down in your own terms, you continue to regurgitate it in your own mind as you move forward. So there's some important information about p-values. I wanted to just write down one other thing that a lot of people did badly on the test was interpreting their results once they had a p-value. Some people knew whether to reject or not, some people didn't. A couple other notes. So I guess I could make these nice and bold so we're clear. So first, second. All right, let's look at a third issue from that first quiz. And these are probably some of the most important issues down here at the bottom, and easy for you to do as well. So make sure you pay attention carefully here. When you get your results, you get your p-value and you decide whether you reject or not, you should write that a very specific way. If you stray at all, it's very, like 90% or more likely that you're going to be messed up. So I reject h sub o. If you have a small p-value, you should say it like this. I reject h sub o because my p-value of whatever was is less than my alpha level. You should have chosen an alpha level. But that's another thing. The book's reading guide in chapter 21, we discussed it a while in class. What's more important, reporting your p-value or choosing the correct alpha level? Well, of course, you have a choice of alpha level, and that's a whole issue in and of itself. An alpha level is a threshold, and it describes the probability of a type 1 error, of course. So sometimes you don't care about a type 1 error, so you can make it real loose, but in most cases you don't want to make any error at all. So you choose a 0.05 p alpha level in most cases, or if you're really worried about a strong criterion of evidence, you choose a smaller alpha like 0.01. However, what's more important is reporting your p-value. Then, regardless of what your alpha level is, you can have written a probability of seeing what you saw or how rare that is, and your audience can decide how strong that evidence is against the null hypothesis. So really, this part is procedurally nice, but it's not exactly so important. Report your p-value and then say just whether you rejected it. But we're going to write it like this. So I reject h sub o because my p-value is small, less than my alpha, for instance. And then you're going to want to say there is sufficient. If the p-value is really small, in other words, if you had a really rare probability, something like, let's go ahead and pick another p-value. Let's say I had a p hat out here on this particular curve. That's incredibly rare, so that would, in that case, I'd have strong evidence. So you can say sufficient, you can say strong, you can say some, that's all fine. But anyway, you should say there's sufficient strong evidence of the fact that the true value of my parameter is other than the null hypothesis suggested. Basically, you need to have a lot more stuff here about context, and that's going to depend on your statement. But this is how you should start it out. You should always start it out by saying, I reject h sub o because my p-value is less than alpha. There's sufficient strong evidence of something, making sure you put that back in context. If it's not back in context on the AP exam, you're definitely going to lose major points here. Okay? So you either should do that. What if your p-value is large? Then you're going to do something like, say, I fail to reject h sub o because of my large p-value. I think this is unnecessary, but for my students who are feeling really solid right now, if you're on the exam and you want to be extra explicit and maybe gain a polish point, you could say exactly what the p-value is. Basically, in context, write this down. Since my p-value is large, there's a large probability of seeing whatever proportion or whatever statistic that you had. If the hypothesis was true, so since that is a large probability of seeing what we saw, it's probably not, you don't want to say I accept the null hypothesis, so let's just be careful here. I failed to reject H sub O because of my large p-value. There is insufficient evidence, or not enough, to suggest some context to suggest whatever about the parameter. Okay, do not stray from these interpretations. You either want to go with this one, just write it like this, or you want to go with this one. You shouldn't stray from the wording in there, or you're probably going to mess it up. Okay. Fourth, and finally, I saw this on a few different quizzes. You should definitely be careful about your confidence intervals. So, excuse me, you should be careful about where you put your parameters and where you put your statistics. So, in a lot of people's confidence intervals at the bottom of the quiz, they had parameters in there. So confidence intervals should always only contain statistical values. Things like p hat, x bar, etc. They should not have parameters. So confidence intervals should only ever have statistics because you're trying to estimate the parameter and you don't know what it is. So don't put parameters in there. Hypotheses in the hypothesis test should always only have parameters in them. Now, not too many people did this. I think they were clear about this already, but ever. That's a big deal on the AP Stats exam. If you have statistics in your hypotheses, that really shows you don't understand the whole conception of inference, what we basically talked about up here at the top, and that's going to lose you major points. You might lose all your points just because of that little mistake. So be careful about that. Alright, so we're going to move on and talk about power more in the next video and look at another example. So I'll see you in a moment.